Welcome, folks. In today's episode of Hanger DX podcast, we're going to talk to Dr. Kat about conversation on cycle time. And Dr. Kat has done a lot of research in this topic, and we will kind of like dive into all the highs and lows and kind of all the challenges associated with it. But before that, welcome, Dr. Kat. I'm really excited for you to have this conversation. Thank you so much for joining us. Can you introduce yourself for the audience?
Absolutely. Thank you so much for the space to come here to chat about this really fun and a little bit complicated topic. I'm Kat Hicks, and I'm a psychologist who studies software teams. And that is not very common in my experience. So I got really drawn into the world of software when I was actually a startup co-founder myself, early in tech, and started working on a tool to help engineers. And I had a background in learning science, empirical research, and doing social science. So I became really captivated by all of these social science questions. So that's what I do now. I try to lead big social science projects that help developers out there in the world. I focus on open science, so open access. You can access a lot of my research, no matter where you are and what you're doing. And I really try to put answers to kind of the black holes that I see at the center of the questions we ask about teams and people.
So maybe I will also want you to describe a little bit about like a little bit of your work in research itself, in the sense like how does
Yeah.
that fit into like where does cycle time fit into, and kind of like obviously a big part of this is durametrics. We started with that, like it talks about like lead time. Is there a
Mm.
correlation there, and like where does your research like revolve around some of these things?
Yeah, absolutely. So I'm a little bit of a hard person to pin down into one thing because I do call myself a mixed methods researcher. So that means I use a number of methods, like a very applied person. I try to use whatever method I think is most informative or accessible to me, So when I look at projects like the Dora project, that started with large ongoing surveys of, software people and asking them to report on their own experience. That's kind of my bread and butter, designing that style of research. So I've led a number of large survey based projects, but I'm also an intervention designer. So I have some research where we have tested for what we call like the mechanisms in social science. So what would help, a developer, for instance, who's struggling to engage with their work? We might lead people through an exercise that targets like certain parts of their psychology. Like, let's say, hey, help you become more self-compassionate. And we have two things we want to do when we do that kind of research. Like, we want to help the person right in the moment, but then we also want to learn, is this a good working model for how this thing works? So that is an intervention study. Lets us kind of test that working model. I find that a lot of engineers just totally get this because they understand like having mental models of the connections and the code base. So I kind of try to do that work, but for different parts of our psychology. How do they interact with each other? So a number of different projects that I have that let me tap into this. Some are surveys. I also do large scale quantitative analysis. And so I think we're going to dive into some of that mostly. And this is an area you might call like computational social science, where you take a big dump of data or information we have about how people are behaving in the world, and then you try to use really rigorous statistical methods and the way that social scientists think about human behavior at scale to at least get a little more clarity about what's going on.
That's amazing. So especially when we talk about like quantitative metrics, like
Mm.
how do you even collect all of this data for your
Hmm.
research?
Yeah, well, I roll my sleeves up a lot, honestly. Sorry, I'm laughing because it is a huge amount of hard work. It's something I take great pride in, though. In the lab that I recently transitioned from, actually, but I was the director of the Developer Success Lab for the last 3 years. And in that project, I built from the ground up our recruiting processes, our kind of promise to the developer community that we wanted to create science. And that in order to do that, we needed them to opt in and join us in our projects and trust us with some of their experiences. And in exchange, we would put out open science for them, right? And that is research papers, which some people read, but it also translates into things like guidance that we give to people's managers, workbooks we've created for software teams. So there's a lot of different things you can get out of science that's not just a research paper, although I'm a big nerd and I love the research papers. So it's a hard question to answer. You can get data in a lot of different ways. So that direct recruiting, that's like the usual thing I do where people are actively opting in. But then there's also large amounts of data all around us in the world, right? So some social scientists might take a database from the public school system and analyze that and find new patterns, and those are things we've maybe invested in as a society. And software engineering data is kind of a mix for me. So I recruit some people for questions that I think are not answered any other way. And then also in our project on cycle time, we had access to a large amount of software engineering data across companies because the organizations had opted into a software metrics tool, which is something you may be a little bit familiar with. So we have these like emerging data sets that I think is very exciting for software to have.
Wow, I'm sure like this is a lot of work. So thank you so much for doing all this research for us.
That's so
Uh,
kind.
I mean, obviously, cycle time is the main topic we want to talk about. So um, let's just start by defining what cycle time is. I feel like
Yeah.
there are many different terminologies used within software engineering. There is like obviously cycle time, but there's also lead time for changes by
Mm-hmm.
Durametrics. There's also iteration time, I've heard a few times. So maybe you can kind of like try to describe what it is from your side, and then
Totally.
we can try to see if there is a similarity with others.
Absolutely. So, one thing I think is really useful to share with you just right off the bat is I never think any variable is the end of the story. Like every time you have a research project, you are doing something that we call operationalization, which is like, again, a real nerd term. But that is the textbook word for, there's a big thing we want to understand in the world. And that thing is kind of unmeasurable, at least in its fullness. So that might be how well we're all working, or productivity, like these really big ideas. And then what we do is we sort of scope it down, funnel it into something that we think is a proxy or a signal or, a variable. So, in social science, all variables are operationalizations, every single one. Like you're never directly measuring everything you could measure. So we knew we have this challenge. There's lots of different ways people talk about cycle time. How can we define it? We have a pretty simple definition in our paper, which was also kind of the definition that these organizations had opted into because they were using a tool that chose this definition. So it was essentially, they were all in ticket tracking systems, and it was beginning of the ticket to the ticket close. And
Hmm.
it's assumed that what those two things mean, is a discrete task is like ready to get started and then it's considered ended. But you'll notice I'm being really hedgy about it, and that's because we know people might input this data a little differently, and that's a big thing that we think about and talk about in our paper as well. But for all intents and purposes, these organizations are at least trying to use ticket start, ticket end as like this is a developer task. Now, what that task contains is like enormous variation. It's many, many different types of tasks.
Wow. Okay. That is hard though. Like, I mean, I can
Yeah,
understand, I can understand every organization if I understand, like, defines tasks differently.
yeah,
And there is like, if you just think about context of Jira task, right?
yeah,
There is epics, which have subtasks,
mm,
right?
yeah,
So all of those
absolutely.
things I can imagine would create a lot of complexities in even understanding this data.
I think so. And one of the things that really motivated me to start this project, which by the way, I avoided doing a software metrics project for like a long time, okay? Because I felt like this is hard and I want to think about it long enough and listen to people in the community long enough that I felt like I had something to say. And so for this project, we looked at the landscape of like how people were using these metrics. I'm sure this audience is a very sophisticated audience about it, right? But maybe I'll voice some of the frustrations you have, right? Which is people make huge sweeping generalizations. And then the number one thing that comes out from the community will be something like, we all work a little bit differently and you're acting like we're all the same and you're not measuring enough context. So our point in this project wasn't really to say we know everything about cycle time or this is the one everyone should use. It was actually to say, we know a lot of places are using this measure. Let's take a look, a hardcore look as scientists at what this measure seems to be telling us, and also see if we can burst some misconceptions about it. Because I had the hunch that people were not approaching this data with like the complexity you need to approach time series data over time with. And that was also a major contribution of this work. So trying not to I go into the math weeds of that, but that's a part I'm very passionate about.
Very cool. So I would love to also at some point get into the actual learnings from your research.
Totally.
But let's kind of at least take step by step. I would first want to understand is um, who is cycle time for? In the sense,
Mm,
there are many different people, right? Like there is developers, there is leadership, and to some degree,
yeah.
there is also customers, right? So you kind of like go at different aspects of it, like who is this data useful for, and if
Yeah.
there are multiple different personas, like is it more valuable for one versus the other? Like who should really care
Yeah.
about it?
I think a fun way of answering this kind of question is to say something like, what would it look to have a cycle time measurement that is for leaders? And what would it look to have a cycle time measurement that is for developers? I'm not sure who it's for right now. And the marketing seems like it's kind of for leaders to feel like they're doing a good job understanding their engineering orgs when doing engineering over time is really hard and everybody's kind of in a state of struggle with it, honestly. So in that, I think, people have their own relationships to these measurements. And I take that really seriously as a psychologist. Like, it's not just that you're measured, but like how you feel about it and like what you think it's
Hmm.
doing. So you can imagine like a cycle time measurement that is just for one developer who
Hmm.
measures their own cycle time and starts to realize, wow, I thought my sleep wasn't a big deal, but I kind of see that it really is. You know, that's great. It's like the Fitbit approach, but that's obviously not what we're seeing marketed out there. We're
Hmm.
seeing this kind of big push for leadership to use this metric to compare between teams. And I think that's basically a different measure. It is derived from cycle time, but you might need to aggregate it differently or account for the measurement in a different way. So, just like you said, there are lots and lots of different kinds of tickets, I've become an advocate for saying there's a lot of different kinds of cycle time.
Hmm.
Now, I do think it could be for customers, quote unquote. In most people don't think that because they think nobody wants to hear about the engineering org. Nobody wants to like hear our nerdy stuff, and that hurts my heart a little bit because I'm like, you know what? When I see organizations that have a deeply engaged relationship with their customers, sometimes those customers actually know, like, oh, you guys are building and crafting, and this thing was harder than you thought it would be, but you triumphed. Like bringing them into the journey of the process of engineering, I think is actually sometimes a really smart, strategic organizational strategy. I think cycle time measures could be a way of showing that sometimes. So we often think this is really punitive, this variable. All that it will ever do is show me that I'm too slow. But what if you actually use it to show that the work was really hard and you accomplished something great? So we're probably aligned in it's about how we use measures, not just what the
Right.
measure is. So that's my thesis.
I mean, I think it eventually also, like some of the things we were discussing before the call, which is
Mm.
my anti-metrics approach, or like kind of like
Mm.
just thinking about staying away from over analyzing these things, partly because
Mm.
it's easy for the metrics can to be used in a wrong way,
I
right?
think
and
that's a
and then I
very
think
practical that's a very practical choice. If you're like, listen, no matter how much work I put into it, people are going to use it the wrong way, who could fault you for not trusting or believing in the metric?
right, and it goes into like the Goodhart's law as well, right? Like if you start
Yeah.
showing this metric, start kind of like trying to improve these metrics, depending on what the intention is, or depending on,
Yeah.
like, I mean, even if you have the right intentions, right? Like
Mm.
you end up in a situation where you're trying to overemphasize on the wrong aspect, right?
Mm.
I generally think that, like, as software engineers, one of the key values as a business is we are trying to deliver value to the customers, right? So that's like the end goal. But like if we try to specify, okay, let's improve the cycle time, what does that mean for an organization, what does that mean for a developers, and are we actually trying to improve the wrong things?
Yeah, I think probably almost definitely. A lot of organizations are trying to improve the wrong things, but some are not. And just as long as we're in the philosophy of measurement, part of the conversation, I have a really balanced perspective on this because I think that measurement is also incredibly important in our lives. And so I always use analogies from health, like you don't want to get, it's very unfair if somebody like measures your blood pressure and then doesn't give you a scholarship, because you have some minor issue with your blood pressure. Like that would be totally toxic, right? However, for an individual person to get that information about themselves over time can be really empowering and important. So I also think that lack of measurement has its problems for engineering organizations. And some of those problems come through in my research. So we did this qualitative research study where I interviewed a bunch of people and we also paired it with our survey. So there's that mixed methods. And we asked people to talk about how visible or invisible they felt that their technical work was.
Hmm.
And this people just score really badly on this. All right. So but developers do not feel like their organizations see or understand their technical work. So I think that's a big problem. Like that's a big burden for developers. I'm not sure that cycle time's the way to solve it, but I do think that it's not just all going to work out if we never measure anything. And some people are getting a little bit lost and scared inside of that because then you get issues like if your boss likes you, everybody thinks you're working hard. And if your boss doesn't like you, oh, well, and I think that's a big injustice for some people. So it's hard.
Interesting. Yeah, I mean, I think there are other aspects, if given that we are also still talking about metrics.
Mm,
So one is I also feel that a lot of this came from uh, to some degree like insecurities of leaders to really
mm.
understand how the organization is performing
I think
or like how
that's
their team is
totally fair.
performing, right? And I
Yeah.
think this also became more severe during COVID when the teams were more
Yeah.
remote.
Yeah.
And I feel like to some degree, I understand certain metrics are still valuable and useful. And by the way, that's why I also love Dora metrics as an
Mm.
aspect of like measuring less about individuals, more about performance of your systems. But at some point, it can get too far,
Hmm. I
right?
totally agree with that. And I think that shows the power of like, we all know there are the things people say and then the things people do, right? And like, if you're inside of a business that is saying, oh, we really care about your growth and your improvement, and then you see your managers get together and they're using measures that you don't think make sense. I mean, you're not going to trust the decision making that's happening in those rooms. And I think that trust is paramount. The research shows, right? It's like all the research on psychological safety shows you could actually have a good measurement, but people will not believe it or quite trust it or whatever if there's not that psychological context. One of the reasons that we chose to look at cycle time and not any number of other things is actually because a lot of software practitioners report that they like cycle time.
Hmm.
So we saw this in a couple big surveys. It's in the beginning of our paper, that were sort of saying, well, you know, in this sea of complicated software stuff, a lot of people give the recommendation like, well, if there's one thing you can do, try to drive down your team's cycle time. So the whole project for me started with questioning like, well, can we tell people what to, they said they want to do this thing. Can we help them know how to do this thing? And my big answer is we found some things that seem like they can help, but you shouldn't assume it's going to work every time or be easy. And some of the things we found are kind of the things you probably already knew. Like if developers get a little bit more time to code, they get shorter cycle times. But that's balanced against another finding from our project, which is we had this really fun measure because of the breadth of data that we had. We had the ability to look at anonymously, so we don't know who these people are, but we can see that there are relationships between their pull requests. So given that, there's the computational social scientists coming in. We can do network analysis, which I think people do not do enough because these are highly related forms of working, right? Like we know people are collaborating a ton. It's not really just about one developer alone. So we were able to look at things like how central to the network is a particular developer within their team and within their org. So we did this thing called hierarchical modeling where we're able to include many layers. Another method tip. I don't think people do it nearly enough hierarchical modeling in this world. So, your team has an effect, your org has an effect. And network centrality, like if you're closely working with other people, that actually drives down your cycle time as well. So these are
Interesting.
two slightly different things, like maybe give people more time and to be alone and let them work together, and I think that just shows as a leader, you have to be keeping things in balance. You cannot
Hmm.
just be like, this is the only answer, this is the one.
Interesting. It also reminds me of the whole conversation around value stream mapping, understanding
Yeah.
like who are kind of like the key players to really deliver the value to the users, or like kind of like just
Yeah.
the whole organizational structure around that too.
I think
Um,
so. I think some of the figuring out the priorities would be really helpful for these teams. Yeah.
right, right.
Mm.
So, kind of like, let's talk a little bit more about practical approach here, right? So,
Yeah.
thinking about cycle time itself, let's say you're working with the organization to help them really understand it.
Yeah,
Uh,
totally.
let's say even if you take the example of like your tasks, like start from the finish to start to finish,
Hmm.
um, like what does it even tell the organization? Kind of like if you come up with like a number, and I don't know what that
Yeah.
number would mean, is it like an absolute number across the organization? Is it kind of like team by team? Is it like sort of like, are we comparing with some sort of like a golden number that is coming out of your research?
Mm.
And how should like one think about like, is it good, bad, or is it focused on like, team health versus like delivery performance? So there are like many different aspects to it. Like how does one even put their head together around it, and kind of like what are they looking for when they're
Yeah.
working on this?
Great question. Okay. So, how do I put us in the right head frame for this? It's like we're doing cutting edge research on a tough disease, okay? Rather than studying something we all know about. So that is really hard for some people. But like if somebody came to me and said, Kat, yeah, let's sit down. I want to consult with, can you please come consult with our engineering org and we want to design, take a stab at cycle time. I do think there are big helpful things that you could do. First of all, do a little pre-surveying to figure out if everybody's logging those tickets the same freaking way. And you won't solve that problem, by the way. Like there will be diversity, but you'll at least know the things that big things the cycle time will not contain. So we point this out in our paper. There's very obvious things that won't be logged in a ticket. People have a really important conversation. There's pre-planning, there's like work that doesn't sort of fit in the buckets of other work, so certain forms of work are like a little bit more legible to the organization than other forms. So right off the gate, it's like really helpful to just say, here's things we know are like pretty likely to be inside of cycle time, and here's things that aren't. And some of those things might matter a lot to us, actually, like the planning. So like we see seasonality in cycle time. Okay, so like across these 216 orgs, which had tremendous diversity, they showed pretty reliable patterns of seasonality. Whole organization is planning a product launch. Engineers are sitting around waiting to know like what they have to do next. There's end of the year effects. So this is going to feel so mundane, but first thing is your organization's seasonality is a huge confound on this data. However, that's very solvable. Listen, have one statistician, which most eng orgs don't have. But this is a thing that we know how to approach when we look at data. Another easy pitfall that people fall into, they just do not measure this data at a long enough time frame. So they are like, I'm going to take a month because a month feels good, and or I'm going to take a quarter because that's what I have to report my team OKRs. The actual data in the world does not care about your OKR schedule or when you need to, report to your VP. We suggest in our paper you need to measure this data for a long time to even be able to know, okay, this is a weird event and this isn't. Because a huge thing, I should have said this right from the gate, but a huge thing is cycle time's massively variable. So
Hmm.
sometimes it's really low, sometimes it's really high. And you need to know, is this an unusual spike? Is this a spike that means something? Or is this like, if I just was looking at 3 months rather than 1 month, I would realize it's a super normal spike. So you have to
Interesting.
be aggregating it at the right time frame. So that's the biggest thing I've told people since doing this work is you're taking too small a slice of time, and just doing more time will solve you a world of problems. But many organizations are not thinking that strategically about it. So,
What is the minimum time you recommend people use?
we had a year in our data set, and we found that deeply useful in part because you get to see, we know it corresponds to large organizational seasonality patterns. I do think it depends on the question you want to ask of the data. So if you're saying, I got to know what's blocking my team right now, sit down with your team and say, forget about the business calendar for a second, what you think you should say. But do we have a sense of how long our work takes? If we observed ourselves for a whole month, would we see kind of a natural ebb and flow, and try to capture at least a few of those? And people will throw out all kinds of things, and even just by going through that process, you might learn. So if it's just one manager who wants to look at cycle time over time, I do think there's interesting stuff you can learn in a single month, because people will have that memory too. You sit down with your team and they're like, oh yeah, here was the big dip in cycle time that happened when we all got stressed or whatever. Or I guess spike in this case. Being longer would be, you know. So I hope you're probably getting the sense at this point that a scientist will never give you a straight answer. Just many answers.
Interesting. Okay, so let's go again. Next step, which is you collected this data. Now what?
Yes. So you collected the data. Let's say it's pretty big. You want to think about, if you're going to do statistical modeling of it, do you have outcome measures? So what do you want to connect cycle time data to? And this has been a truism that I've repeated across my whole career doing science in tech. People don't think about outcome measures enough. They think outcome measures are just obvious and that we're just going to have them because the outcome measure will be like money and success and everybody happy. But outcome measures are super, super hard to define. So there's a first step, which is just wow, can we get the cycle time data? Can we observe it? And can we know what's left out of it? So kind of just creating that observation at all. But most people's questions are predictive questions. Most people have causal inference questions. They want to know, do shorter cycle times really matter for our org? So you can do this. It's not impossible. It just takes a lot of work. So we defined some outcome measures. That's how we were able to have findings in our study. That included, well, in our case, we were looking a lot of the time at just what predicts a shorter cycle time, because the developers told us, the practitioners who tell us generally that's a thing they want to do. So, in that case, cycle time was our outcome measure. That might be the case for you. You might already have things that you're doing in your environment. You just want to know, do they associate with cycle time? And you're welcome to use our whole, we have our whole code available from our paper. So honestly, if someone wants to sit down, do the same statistical modeling we did for just your organization, it is completely possible. There's a few recommendations I would make. One is, like I said, the hierarchical modeling is so helpful because it is just information you're cutting out of your modeling if you don't include team level variables and not just looking at individual developers as if they're isolated units, which we know they're not. I think it'd be really fun to pair cycle time with more qualitative data. And so reach out if you want to do that with me, because I'm super excited about being able to break cycle time down into different kinds of cycle time, actually. So that might be something you have the opportunity to do if you run a lot of developer experience surveys, and you could actually say, well, are people more stressed out when the cycle times are longer, or what if it actually, there's no correspondence? And so that could be a signal that some kinds of lawn cycle times are bad and some kinds of lawn cycle times are good. Maybe you need that other variable in there to be able to sort those things. Is this making sense? I feel like this
Interesting.
got really wonky.
Yes. No, no, I think it's interesting because like the way you describe cycle time is generally you're talking about organizations are comparing within a period of time when cycle times are good versus bad. And I'm also curious from the other perspective, which is like if you have, let's just say, I mean, hypothetically, maybe it's not true, like you have
Mm,
consistent cycle time throughout the year. Um, does an organization know whether that's good or bad?
I
Is it
doubt
like
it.
is it like, I mean, do they want to improve this somehow? Like, because my understanding is as an organization, they would want to say, yes, we want to ship code faster. Who does not? Right.
Right.
So how does that play out? Is it like, are they comparing with like some sort of like a, gold standard graph somewhere? It's like, oh, this is how it should look like. For instance, in case of Dora metrics that tell you if you're
Yeah.
in the top quarter, like this is how your kind of like organization is performing.
Yeah, I'm very skeptical of all of those generalizations of the benchmarking approach that a lot of places take. And I have a lot of compassion for why we do it. I know that we really want to know where our company falls. And I know, that it can be very useful to say, well, there was this, but is this if when I was teaching research methods, this is like what I would tell people. Listen, just ask yourself, how did we get this data? And does the data answer all of my questions? And maybe it does. I'm not going to tell anybody, hey, run your thing the way you want. But if you look at Dora benchmarks and it's basically clustering survey responses, then you into quadrants, that's a certain kind of benchmark for survey responses. I'm not so sure that it answers all of our questions about the outcomes that are tied to that. So, like I said, everything is an operationalization. But I think the best approach, if I think like a strategist, is start to figure out a few success outcomes that truly matter for your individual organization. Because your individual organization looks, I guarantee you, because I've done the math, looks very different from other orgs. We see incredible amounts of what we call heterogeneity, like variance, highly variable, different patterns between organizations. That leads us to believe you are going to need to set your own benchmarks because there's so much other context inside of that cycle time. So one person's average of 5 whatevers and another person's average of 5 whatevers on cycle time might mean completely different things. So again, not a super fun answer, but I hope like a validating and helpful answer is like, you're going to need to create your own measurement strategy and experimental like research process if you really want to say I'm going to understand what's a good cycle time or a bad cycle time in my org. And I think that starts with lots of observation,
Hmm.
and then almost treating it like the way we analyze incidents, which I think is sometimes way more sophisticated than how we understand our teams, and say, well, something really big and different happened, like let's get curious about that. Does it matter? Sometimes it matters, maybe sometimes it doesn't matter. There's going to have to be like a detective work here, and we don't see a single threshold or like a golden number coming out of this, because what we see is even for a single developer, their previous average cycle time is not a good predictor of their future cycle time. So
Interesting.
there's so much going on that's bigger than cycle time that has to be included here. And that was like a big flashing red light warning for me to the organizations that are trying to say, well, let's just use averages of cycle time to say a developer's doing well or not, because the averages are really flawed.
Right. And I also kind of, I think, I don't know how much that applies to cycle time, but one of the things
Mm,
we used to talk about is like, for as the more senior you get, there is a very good likelihood lesser code you're writing. You're just
totally.
enabling others to kind of like write more code. Do you think those kind of aspects within the organization also impact cycle time?
I would believe so. I mean, I think a lot about the fact that you're probably getting this impression from me because I've done a lot of work that's just asking, are these even the right measures? And so I know we share that question, right? And I think that sometimes, something is a pretty good measure for a certain kind of work and then a really bad measure for a different kind of work. And we have to start to be really mindful of that. Like, people are not going to put their most sensitive work inside of a ticket that might be seen by somebody, right? We all do these things in our workplace that are very strategic and understandable. And I don't think the answer is to ask for surveillance that's inhuman. I think the answer is we need a strategy that's thoughtful um, and I think that's one very obvious pattern. You're a senior person. I had a lot of staff engineers say, I help everybody else's work, and then my work does not show up in any of these measurement systems.
Right.
I've heard infrastructure teams say, I don't even know where to put myself. Am I a developer or not? And like, I made a change that like affected, 3,000 people, like all got better, but I don't know if I get to count that. So I actually care very deeply about those things because I think a lot of people are suffering. And again, it's that visibility thing. They're not getting the visibility. So cycle time's clearly not going to be the answer for all of that. And I think sometimes even knowing, well, just like what you started this with, who should we use this measure for and who does it leave
Mm-hmm.
out is a really helpful question to bring to the leadership.
Hmm. Interesting. So, uh, when we're thinking about, like, you did say a little bit that the data is anonymized, but like,
Mm-hmm.
at what degree do you think cycle time measurement is a good measure, or like we'll get like more like data that indicates some problems or like some issues? Is it like, are you measuring at a team level, are we measuring at a user, like an individual developer level, are we measuring at like,
Yeah.
okay, depending on different types of personas within the
Yeah.
organization?
I think there are multiple ways to add richness to this measure. So we can add richness by adding context. Like, let's say you have one thing that's really fun about trace measures, like software measures, right, is like they run in the background. And so we're getting to this place where we've just instrumented a lot of stuff.
Mm-hmm.
So we have this I do find that very exciting as a scientist. Like, we have this, it's really cool. We have the opportunity, if organizations could be brave about sharing their data, which I'm not sure that they are, but we have the opportunity from the scientific point of view to do almost like the epidemiology of software engineering, right? So that, I think that needs to be big. That needs to be across organizations, because then you start to be able to understand what is generalizable and what is really specific to an org, and where are their differences and where are their similarities. And like, having clarity about all of those levels is super important. And then it's just kind of madness trying to get an organization to be honest about like their internal workings. It's all through this filter of, oh, our cycle times are basically this. And then you say, okay, are they really,
Right.
So that needs to be big, I think, for that really big scientific insight. But for working scrappy practical teams, I think you can add richness in other ways. Let's say you're running a developer experience survey, like I said, and you just have a little bit of a measure that's going alongside the cycle time. It'll be at a different sampling rate, right? Because people can't be bothered with surveys all day long, but it'll still be, you can still make it over time and then say, okay, we did this thing and it drove down our cycle times, but it sure stressed the developers out more because now, and that could be a really, that combination of variables. So that's a way to add richness, even with completely flawed metrics, right? Which all metrics are flawed, in my opinion. In psychology research, all of us are just trying our best. So,
Interesting. Do you think like organizations uh, get value by just measuring cycle time in itself, or do you think if you're measuring cycle time, you would want to
yeah,
also measure other aspects to kind of like, for instance, you also talked about like surveys, sort of like developer
yeah,
sentiment, right? Like, so do they have to go hand in hand, or you can kind of like in some ways try to get value from measuring
yeah.
cycle time?
I think clever and thoughtful people can get value out of the most imperfect and limited metrics as long as they are being really thoughtful, right? And so imagine you only have cycle time. You can still observe it over time, right? Observationally map it. And so you can learn some stuff. You can learn, wow, every December our cycle time just goes really looks amazing because everybody's in a huge rush to close tickets, right? We have our working lives and our lived experiences, so we can probably fill in. That's a completely reasonable thing to do, by the way. Like,
Hmm.
kind of, you can make guesses. Those are hypotheses. You might want to test those a little bit, but you often need to bring a mix of like the data and your working self as a developer and kind of say, this is a pretty reasonable explanation for why the data looks this way. So you can use cycle time, I think, very reasonably to learn things. And you might learn something like, wow, I have a team where the cycle times are incredibly variable. Like, some people, for some reason, some people have really long cycle times. That could provoke any number of questions. Are we using our tickets differently? Is one person the person who's helping everybody else? So I don't think we're going to answer all the questions everybody has, but I still think you can certainly observe the world, right, through one measure. Does that help as an answer?
Yes, yes. I think okay, so we are getting close to time, so I want to kind of like at least give a little bit more. Think of this as like, if you were to suggest a playbook to an
Mm,
organization on what to do with the cycle time, how to measure it, like how to
yeah,
analyze it. Uh if you were to like maybe answer that in 1 to 2 minutes, like what would that look like?
love it. Okay. We need to understand the environmental drivers of software team performance. So you need to start to get a sense of what are like the big shared things that are driving teams down, in my opinion. That's what the evidence points to. Now, my biggest immediate recommendation is you're probably going to need a mix, I would say, of ways to measure this. You could use software metrics and developer experience surveys, but that might sound to people like I'm proposing this like just massive investment of time and energy and focus, and that might feel unattainable. But you can approach this in a scrappy way too. So let's say you invest in just a little bit of observing the data you have. I'm a huge fan of just sitting down with your teams and saying, can we talk about where you look for data, where you think there's interesting patterns, things you think will never be captured by data? The scrappiest, smallest team in the world can do this, can get like a little, well, we're never going to capture mentoring. So let's like make sure we kind of write that down and know that. Um, so that playbook for me starts with observing what you have right now, deciding
Mhm.
your highest priority investment you can make, and that investment should be on, I think, data richness rather than data hugeness. you know and maybe you have data hugeness, right? Maybe you have, like what we had, a massive dump of software engineering trace data. A lot of people do. You can look at our paper and use our code, spin up a little R script, and gosh, if this is not too edgy to say, stop reinventing the wheel.
Huh.
Like, take what experts have already done, try it, see if it works for you. Don't bog yourself down in having to become a statistician or something if there's already work out here to say, here's how you look at time series data, here's how people make obvious mistakes. um, I like to say to engineers that people do want to help you. Like, we are out here like hoping to help you, and maybe not enough of us, but like, you don't have to be alone with these hard problems.
All right. I feel like this podcast has gone by so fast, and there is like we're still scratching the surface here. We may have to do like another version at some point, but like
I'd be happy to.
one is I will also share some of the references in the show notes so people can find your research, maybe also the code and like all the stuff that you're talking about. That way, it
Absolutely.
could be a good starting point. I feel like there is still a lot more to dive into, and yes, maybe this will
Absolutely.
be another
And
time.
I should say that the lead author of this cycle time project is the statistician lead for my lab, John Florney, who's amazing and is looking to connect and talk to people about this project all the time. So just to say his name out loud, really loved working with him on this project.
Amazing. Thank you so much. This with that, Dr. Kat, really enjoyed this conversation, and yeah, I look forward to hearing more about your research.
Thank you so much.